computer. All right. So first thing I'm going to do, of course, is make sure everybody has read this and understands what the problem is. So if you haven't looked at the algorithm before, take a quick second, read it quick. It's not long, so we'll do like a minute. So just read the problem quick, and then what I will have is just people take turns. A couple people just take a turn to describe what they see, what the problem, like what do they feel is the problem. Again, in your own words, without explaining the solution, just explain what the problem that we're trying to solve is. Not how to solve it, but what are we trying to do? That should be enough time to see what the goal of the problem is. So can someone please describe the problem for me? We'll have a couple people go. So again, I won't be telling you if yes or right, good or bad, or anything on your response. Just want a couple people just let me know in your own words, what are we solving?
You're given a base 10 integer, which is like a regular number for us. And you want to convert it to binary. And then based on the binary representation of that base 10 number, you want to search for the maximum consecutive ones, the maximum amount of consecutive ones, and return that.
And then what we return, what base would that be in, just to confirm?
That would also be in base 10.
Okay. All right. Making sure we're on the same page there. Yep. Anybody else?
I agree with Mike.
Yeah, I don't have anything to add that would be more succinct than that.
All right. Yeah, that's pretty much, yeah, you said it pretty much right, yeah. Given an integer, convert it to binary, and then find the maximum consecutive ones and print that count and that count. So what is the key, if we had to break this problem down into 2 key steps, and so this is one of those first things to do with any sort of algorithm, that another technique that you can do is to break it down to what are the key steps that we need to do. So have an int, we have an integer, and the result is to get the consecutive, the count of the max ones, the binary representation of the int. So what we start with, and this is one of the things to begin with, we start with an int. That's really all we have, right? So what are kind of the key things we need to do in this case?
First thing is to convert that base 10 integer to a base 2 integer.
Convert to binary. That's my first task. Can you do? I can't do anything until I do that. After I do that, what's the next kind of process that we have to do?
We then have to take the binary we're given and iterate through that sequence to see how many consecutive. Oh, okay.
Start simpler.
Loop through that binary.
Count the ones in the binary number.
But we don't need to loop
Say
through.
that again, Travis.
Count the ones in the binary number.
Very close, but I want something a little bit more on that.
Count the consecutive ones.
Yeah, consecutive ones are good. You could also just accommodate this to find max consecutive ones. We can determine how to do this later. That's that concept. We're trying to say what we're doing, but how to do these things we can figure out later, right? My main tasks here is first to convert to binary, convert the integer to binary. And then after that, I need to find the max consecutive ones. And then I return that. Now that's the first kind of like the high level stuff. And that's the first thing to do. Find out what you're trying to do without saying how to do those things. The how comes later, right? So first start with your steps to get to the solution by finding those steps of like, what are the major steps that I need to take in order to get to the solution? And now once I have those major steps, I can start breaking them down into smaller and smaller pieces. So yes, finding the max consecutive ones is now I need to count the consecutive ones. That's how I find the max consecutive ones, is by counting the consecutive ones. And eventually I'll find the maximum. So that's one of those other little techniques that you can use in solving algorithms, is start with some pretty vague high level steps, and then you break down later the how to do those items. Does that make sense? That's another technique. That's one of the interesting things about algorithms. There's multiple ways to approach an algorithm, and not every way will fit for every single algorithm. Sometimes finding these major steps may not be easy in certain algorithms. In other ones, knowing the how of every step isn't very easy. For example, unless you already know the method to do this, how do you do this in Java? You might not know, right? And so there isn't, and in the very first time, you might be like, I actually don't know how to do this yet. And of course, hopefully should pop up like, there's probably a method. If not, then I'm gonna have to create a method. But first I should check to see if there's a built-in Java method for doing that, right? So that's the key thing here, is that you're not always gonna, in every single algorithm, be able to find the how to do every step. But knowing what the steps are can help, one, with your searching, and can help you with breaking down into those hows. So definitely can help to start first with the high level steps on how to solve the problem.
So
key items-
theoretically, every language has a way of converting to binary, theoretically.
It should. Like you're dealing with a bad language. Since, computers work in binary, we did kind of reveal
Sure,
that yesterday.
Right.
So if you have a language that cannot convert an integer to a binary for you, it is not a good language. And honestly, the
he's
best way to
saying
do
there
this,
are languages.
there could be. I would assume that white space might not have a method for that. There are joke programming languages, just so you know.
Of course there are.
Of course,
The FU.
wasn't going to do that one, but let's ignore that one.
Yeah.
But white
I think we're
space
getting off
is
topic.
simply this. This is my point, and this is going to be the only side we get into it. Just know that there are tons of languages, and this is the most I'm going to give you on this one. Hello world is all this. It's all just white space. So yes, there are languages, but if you have languages that don't convert to binary, probably don't use them, and you might be using a joke language. So what I was going to do with that, actually, before we get that, is, because yeah, there's tons of joke languages. I'm not going to get into that. Just looking at this one, and that's it. All you need to do is just, one of the key things here is just to know, since we know that step, all we need to find the built-in system item for our language to use our language name, Java, and then what we're trying to do, decimal to binary. And keep it simple. Don't worry about proper English. Do not put in like how to or the way or any of those like ways. You're not talking to a computer when you're doing a Google search. You're not talking to a person when you do a Google search. You're talking to a computer. So just use very vague, very to the point phrases, and that's going to get you your best results.
Can I ask a question before you go any further?
Yes,
Why did you use decimal and not integer?
because integer is not really what I care about. I'm more cared about the bases. I want to convert base 10 to base 2. So decimal to binary.
Okay.
Yeah. So if I'm, because you can technically store in an integer a hexadecimal number. If I type out hexadecimal with the 0x, and then I can type in 0x hexadecimal, or yeah, 0x I think is hexadecimal. So I can do 0x and then type in hexadecimal, and integer will actually store that number. Integer doesn't necessarily mean decimal. It just means a number. And for all intents and purposes, your computer stores an integer as binary. You may enter it as decimal, and when you ask it to print to the screen, it will print in decimal, but it is stored and saved as binary. So integer to binary doesn't really make sense.
Never mind. When it said
Okay.
decimal, I was thinking like a float, not.
Oh.
I
Gotcha.
didn't. Just keep going. I
I
get
got you.
it
No
now.
worries. Yep. Decimal is what we call the base 10. I get it now. Gotcha. Yeah. Decimal is deci 10. Yeah. Gotcha. All right. So yeah, click on the first one, and we see that the integer library has a 2 binary string method built right in. Nice and useful, right? Why, Matt? Why is that face? I am concerned.
I built this method out myself, not knowing that it existed.
Oh no.
What, converting to
sorry.
binary?
Yeah, it
I mean,
does
yeah,
the exact.
it's not that hard.
No, it's not that
No.
hard, but it took more time than I wanted to.
I mean, yeah, it's a little while loop.
He
That's
did
all
say
it
if
is.
it didn't exist, you would have had to make it on your own. So
Right.
Yes.
But point is, it exists, and now I feel silly.
now you
Oh.
have 2 methods.
Now you know something you didn't know before.
Mhm.
Right.
You got better at coding. You improved.
It's all good.
Who knows? Maybe one day you'll need this knowledge.
You might. I actually
Build
would love
your
to see
own
that
library.
code, though.
I wrote it out. It's fairly simple.
Yeah.
Yeah, but and one of the things I like to do is my reason for doing this is just again to help save time in your interviews challenges. So if you have an algorithm interview challenge, you probably don't need to recreate a binary converter if there's one already existing. Save time. Use the built-in method. And this is one of the things that you're okay with Googling for. You're okay to Google how to do a specific step that's very, very specific, a specific method or looking for a method. You don't want to look for the solution to an algorithm, but you can look for how do I convert, what's the built-in system for converting a decimal number to binary? That's okay to search for, and that's something you are okay with allowed to search for. That's something you need to be found quickly and shouldn't take that long to Google. Googling how to do an algorithm can take time, it's going to be slow, and again, you'll likely get flagged for plagiarism. So just do that. So now we have that. So first thing I'm going to do is do string. Bin, we'll do bin. B string, that's weird. Equals. Sure. Dot 2 binary, there you go, 2 binary string. Pops right up. And all right. Now that we have a string that is our binary string, which means if we're, again, this is another technique that would be useful, especially in the beginning of algorithms, is to maybe even write a comment to understand where your stuff is. So we know that n might be equal to, what is it, 125 they gave us? There we go. 25. And now we know that our bin is going to be equal to string 111101, like that. So that's what we have right now. Now we need to find the max consecutive ones by counting the consecutive ones. Well, how do we count consecutive ones in a string?
The for loop.
All right, well,
Substring.
we can do both. What's
Or
that?
for each.
Substring.
I heard substring, I think, and I heard for each, and I heard for. I want everybody to take a turn on whoever gave you them, explain how your item works. So the for loop, how does the for loop work? How are we going to use how will we use the for loop? Try to explain it.
You loop through the length of it and count each value.
You,
Because you already
How
have
though?
an
You
int on
use-
the line 23.
String. So, again, how do we iterate through the string? So what are we going to use to iterate through the string? Well, I'm trying to get you to describe a for loop a little better.
The length of the string.
Do the length. Well, yeah, use the length. How is the for loop going to let me access each individual character?
Character at. Or char at.
Index. There we go. Chart index. So keeping that constant, we know that we have the index phrase as well. That index phrase is something we also want to be aware of. So index, we can use char at with the index, and for loops give us an index. For each, someone else, even if this wasn't your recommendation now. I think Jeff might have said for and for each. So
I did.
yeah, so someone else can give you the for each. How is the for each different from the for to allow us to iterate through the string?
We iterate through each individual character of the string directly.
Got it. And then I heard someone say substring, I think. Mike, I think I heard. Said substring.
That was me. I had the idea of substring, but I'm not sure if I fully understand it now. So
So you wouldn't know how to use it?
I was thinking that it breaks it in, like it would break it into the ones and then the 0, then the 1. But I'm realizing that it would break it into each possible composition of it.
Okay. Anybody else? Any other ideas?
I like his idea better because, well, never mind.
I have an
me hear
idea of what he's
substring
trying-
does.
I know, I think I realize what he's trying to do, and I don't think substring is the item he's thinking of.
Yeah, I'm
So,
thinking maybe splice.
not splice. Splice is for arrays. You're thinking split.
Yeah.
Split allows you to give, that's a weird way of just showing it.
This uses a
Um,
regex.
Regex, you can also just give it a string as well. But really, you can just give it a character. So you can give it a character to say, hey, split on this character, meaning remove this character and use it as the separator. Is there a character that we can split on and then allow us to group things together?
Yeah, the
That's
0.
saying yes. Ah, yes. The 0, right? If we split on all the zeros, we'd be left with a bunch of groupings of ones.
Wow, this is
Alright.
clever.
It is. I forgot about
didn't
this.
even know
This
this
is
was
what
a
I
thing.
was trying to think of. I got.
I actually forgot about it. This is one of the solutions I didn't see before, and one I have come up with before. I actually can't remember which one is considered better or faster. Yeah, they're very, very close, but it is an interesting one. Yeah, so not substring, but yes, the split item. So split, we can then split the string into a string array. Ones. So let's take a look at, and so what we're going to do actually is we're going to, trying to think.
You said
I
a
would say-
group of ones, but it's not a group of ones, is it?
Each
It's gonna.
element of the string is going to be a group of ones. Because if we see this, we split on the 0, what that does is turn this into that.
Ah, okay, I see what you're saying.
A string of string. Well, actually, that's wrong. This, sorry. That. Better representation. It'll do this. That's what split does. It takes that character and turns it into a breakpoint, eliminating the breakpoint and then doing that. And even in a situation, let's say we had this number, we wouldn't know how that would be converted.
It would only split on the first 0, so it would be the same as last time, but there
Are
would be
you
a
sure?
0.
It splits on every single 0.
Oh,
Yeah, since it goes into an array, it splits on every instance of that.
Yes.
Whatever
What I
you
believe it'll do is it'll
parameter
actually
is.
create this. it'll create a blank item as well. So it will create 2 breakpoints. And so one of the breakpoints will just be an empty string. Java may not do that. It might still do this output potentially, but I have seen splits before do this, where there's 2 breakpoints in a row. So this is the output we'd expect for that.
Yes, because you can break.
But what I will say,
With the empty quotes.
since we're not sure, couldn't we just write a quick JavaScript to test what would happen?
We could.
Yeah, how fast would it be to how quick could you create a basic JavaScript to just test what's happening?
Just did in like 4 seconds.
Right. Ready? I have IntelliJ open right here. I was going to create a little what can I do this thing? I'll do this somewhere right in here under main.
Looks like you've been running that server for 4 days.
Your
Cliff.
car rental application at the very bottom of under security
your
that'll have
main.
a main in there.
Yeah, I don't
That's
want to do
where
that one though. I'm just going to
Oh,
open
okay.
up the what was it? I'm going to open up our algorithms project quick.
Oh, okay.
That's why I like having that. This window. For Flint, I'm just going to do new Java class, tester. Main method, and that's it. Now I'm ready to do some testing. Ready? I'm just going to create a string. 3501. Test 2. Yeah, it's fine. Yeah, I'm calling it toString on an array, but it should still print it, right? It can print out arrays. We'll find out. Oh, I just printed, I just did tree. Oh, right. How do I print an array again?
Arrays to string.
Thank you. Java's pain on that. There you go. Now we can see what it does. This is a very key skill to do during like hackering tests and things like that. Just create a quick test file and just test what you assume is going to happen. Don't always just assume you know what's going to work. This took me like a minute, right? If that. So it's better for me to test my assumption versus rely on an assumption and be wrong and waste time than trying to fix it later, correct?
Yeah.
By
Right.
taking this 1 minute to just confirm my assumption on how something's going to work, I'm going to save myself problems later on, right?
Absolutely.
So this is one of the, again, it's a huge, huge thing I do a lot of times when I'm dealing with algorithms. I might have an assumption on how my code's going to work. I do not move forward on an assumption. If I am not confident that my assumption is correct, and if I'm not as confident because I haven't done it before, when I say not confident, that doesn't mean I'm like, oh, this is definitely how I'm expecting it to work. When I say not confident, like, no, this is definitely how it should work. Let me check that. I can be confident in how I expect something to do it, but if I don't know this is going to work a certain way, instead of basing it on that assumption and ending up having a problem later, I'm going to go ahead and test it. And that way I know I can move forward in my code knowing that what I'm expecting back is what I'm going to get. Instead of being like, well, if I get back what I'm thinking I'm going to get, it should do this. And then I suddenly have a major bug. I'm like, all right, where the problem is it on this assumption or is it with what I'm doing later on? if I have a bug moving forward now, if I was to move forward with this solution, if I have a bug moving forward now, I know it's based on what I write after, not based on my assumption. I've already ruled that out. And that way I know that if I have a problem later on, it is not based on what I'm assuming I'm getting back from the split method. It's from how I'm handling the results from the split method. So testing your assumptions can be a very, very useful item. Can help save you from dealing with a lot of bugs later on. For that. What I'd like to do is actually first, though, I want to go with one of these two first. This is where most of you would probably go with on this one. You'd probably approach it in this way normally. So I want to start with these ones, but then I'll show you how we can use this one. But this is another one where this solution, I will guarantee for a lot of you, you're not going to think of this unless you have familiarity with splitting, this familiarity of splitting strings and breaking strings apart. So not thinking of this one is fine. It's one of those kind of unique solutions that isn't so obvious to you. When you go to approach this as a human, you're not going to think, oh, let me just put commas in between all the zeros and then I can see all the bundles. You're not going to think of that. So that's not an approach that is easy to fall upon. It's something that will just pop up the more you use a string split method in other algorithms that then makes you think like, ooh, I wonder if I could use split in this because I'm familiar with that method. I'm familiar with that approach. So be aware that a lot of these solutions are going to have a unique solution like that is very computer science focused, but may not be obvious to you unless you've dealt with that item before. And that's why solving algorithms can help you to see things in a weird, kind of more unique sort of way. That makes sense?
So if we were to do something along these lines in an interview, would you consider that like showing off a little bit of your understanding of how methods can work within a language?
I can see that, yeah. I would definitely see a unique solution as being very interesting and show that you have more experience in writing this language and working with this language. You've dealt with this language a lot more. It just shows what it really shows me is familiarity with the language, comfort with the language, and yeah, that kind of thing. It'd be think of it as a way of like when you're trying to go somewhere, and think of being the passenger in a car of someone who is native to a town and someone who is out of town, and how they travel and how they drive around that place.
Right.
What is the native person going to do differently?
Shortcuts.
Right. They're going to know which roads are faster, even though it might not seem the fast way, right?
Yeah.
They're going to know, oh, if you go this way at this time of day, it's actually faster to go this way. If you go that way, you're going to run into a traffic jam. Right? Yeah. That's one of those key things. That's the difference. Are they both going to get you there? Are they both going to get the job done? Yeah. So you'll probably take them both, but it's not going to disqualify the non-native driver. You're not going to disqualify the non-native driver for not knowing those secrets, but you're definitely going to be more impressed by the native driver and more willing and more likely to call on them later on, right? So it'll definitely give you bonus points in the interview, but not doing that won't disqualify.
The keyword there. The efficiency being the main factor there.
And that's partially why, no matter what level of the interview, no matter a lot of companies nowadays, no matter what level you're applying for in the interview, they'll give you the same problem because it's they want to see how you solve that. And they're seeing, are you going to solve it like a native Java developer or a out-of-state, not a Java developer? So Arnell gave the other analogy for this is like you ask a 1-year-old, a 5-year-old, not a 1-year-old, but a first grader, a third grader, 5th and 6th and 10th grader to draw a car. And what's the difference between those people? What's going to be the difference that you see in each one of those drawings?
Detail.
You set me up for a joke. Yeah. I'm not gonna do it.
No, not right now. Detail, right? The higher grades are just going to put more detail on the car, commonly. Is it possible that one of the lower graded students could actually put more detail than you were expecting that person to put in?
Absolutely.
Of course. And that's when someone's acting at a higher skill level than they're expecting them to. And that's why you'll see companies give the same problem to every applicant, no matter what skill level they're applying for, to see, do they have that detail? And so things like this shows more detail. That's all it does. Doesn't mean you can't do it. Doesn't mean you can't draw a car. Just means you can draw it with more detail or solve it with more detail.
Do you get more points for solving with creativity?
Yeah, because again, it shows a higher level of familiarity and comfort with the language. 11 get bonus points, but yeah, like I said, not doing it won't disqualify you. What disqualifies you is if I ask you to draw a car and you end up drawing an elephant.
In some parts of the world, that is a car. Just saying.
All right, well put.
Mode of transportation.
There you go.
Means of conveyance, but
Fine, I'm drawing a house. But that's hopefully you're getting the point on this. For now, though, I do want to target these two first, because these also have a little more interesting on how do we approach these. We'll do one of these, and then I will showcase how to solve it with the split version as well. Let's approach this one first. 1 second, actually. Sorry about that. Okay. Yeah. Any other questions on the analogy and that concept? Sure, good before we move on. So which one do we want to use? The 4 or the 4 each?
For each.
Vote there, got 2 votes for 4 each. I got a nod from Matt. Anyone was like, where'd the second vote come from? I was like, where's the second vote? I didn't hear anything. I want more opinions.
4 each is, I'm good with either 4 or
I
4
think-
each.
I think 4 each, because we don't really need the index.
How about me? Yeah, I can't really think of a reason to have the index. That makes sense. So 4. And now you have to understand what does it return for? How do we get that out of there? So for I can use var for 2 seconds until just that way it won't yell at me until I figure out what var would be. Never leave var though. Unless you see samples of the company's code that uses var themselves, don't use var in an interview unless you see them using var. That makes sense?
Yeah.
You'd rather be more specific for a company that is a specific developer than be under specific for a specific company. So if the company is a strict development company, you want to appear strict. For letter, or we can say digit actually in this case, because it is a digit, even though it's a string. For digit, colon, bin. Now, this is not going to work by default. Why not? So strings are not iteratable. How do we turn our string into an iteratable?
Yeah. You'd have to make it an array.
How do we do that?
Char array.
What's that?
To char array.
Ah, yeah, that could work. 2 char array.
Could also declare bin as a string array, adding brackets at the end of the string variable.
Right here.
No, sorry, not next to the variable, directly next to the declaration of the string data type.
Right here.
Yes.
Will that work for what this returns?
No.
No, that returns a string. So we're no longer accepting what 2 binary string returns.
So
I'm
instead of
thinking a step ahead.
so
you
instead
are.
of var,
Why is that upset?
I think you might have to do it outside of the loop.
you'll have to do char digit.
var should accept whatever I give it, though. Weird. Interesting how var actually wasn't able to tell what it should be. Interesting. All right. var, of course, like you said, tells the compiler, the Java compiler, to determine what it should be based on what's after it. Seems like var is having trouble deciding what it should be in order to take that. So we'll just tell it, oh yeah, you're going to be a char then. Each iteratable from the char array is a char. Each individual element is a char. There we go. Again, just to clarify, just to make sure everybody's on the same page here, again, there is the for each method. So again, I probably should have clarified that instead of saying for each, this is the for in. This is kind of how you differentiate. This is the for in loop, even though we'll call it the for each as well. The for each is a method that exists in Java, but again, that is a method, that's a function. You cannot skip things, you cannot use continue or break. It is very different. Make sure you do know the differences, because that can sometimes be an interview question of like, what are the difference between a for in, and for each? Those can be interview type questions. All right, so we got that. So now we know we can at least go through and determine if our char is a certain character, right? Now, how do we want to calculate or count our max consecutive? How do we find the max consecutive? Now, instead of you guys telling me the answer, think for a second and be like, how would I need to, so we got to think of a computer. And as a computer, one of the big key things there is they are very, I like to imagine them as being very tunnel visioned. Computers are very, very tunnel visioned. They can look at single things at a time. They can compare things side by side. So the maximum I can look at is 2 things at the same time via variable and stuff. And I can compare them. So even though I can look at this and see this giant group here, I can't look at that because the computer is going to be looking at this, and maybe I could get it to do this. And so at any point right here, as a computer, if I do this quick, I do something interesting. Can I do this? That's fun here. So we can get away with this. That's see-through, so that's wrong. That not going to work, I think. Should be very, very interesting. Let's see. Can I do this? Well, I'm trying to think of doing. Let's try something really, really interesting here. Bear with me on this. Oh, well, we cover it on this screen. Dang it. Nope, can't do it. I was going to write and then hide it, but we're just going to have to use our imagination then. So as a computer, like as a human, I can look forward and see where the largest group is. But if we know a computer can only look like 2 things in, with these 2 numbers here, do I have any idea how long that string of numbers is? How many ones are here after this one right there?
After that grouping, no.
No, right? And with our for, since we're not using a for each, or with our, since we're using a for in on the for each, and we're not using a for loop. Sorry, I don't have the index. I can't really access the second one either, can I? I have no way of accessing the next index or the next element in the array because I don't have the index. So really, I'm looking at it like this. And so I don't know what's after this, right? I have no idea. I have no way of knowing how many ones are in a row after this number. This is what a computer sees. And after I go through the first one, what happens is that I'm technically doing this. And again, I now no longer know how many ones I've seen necessarily or how many after, right? So thinking like this, if I had to force myself to only look at one number at a time and I can't look back and I can't look forward unless with what I'm currently looking at this number, how am I supposed to count each number? How am I supposed to count how many ones are in a row?
Separate variable.
Yes, because if I'm doing that, I'm going to be saying 1, 2, 3. Well, that number I'm speaking out loud is a variable that's changing, right?
Mhm.
And that's another thing to keep in mind is as you do something, you may not think of it, but when I'm counting these out loud, 1, 2, 3, that number I'm speaking out loud, well, that's a variable. So now we do need a counting variable to count the, what is that number keeping track of though?
The number of ones.
Just keeping track of the number of ones. Is there a better,
Number of
more
consecutive
descriptive?
ones.
Consecutive ones.
Almost is the name I want to use. We'll see if we can change that later. So int number ones. Very, very descriptive. Initialize it to 0. So now here we want to increase that anytime we see a 1, right? So if digit equal to single string, quote 1. remember, it's a char. So double quote is going to compare a char to a string, and that doesn't work. We want to compare the digit to the char to a char. Now, we don't need to use the dot equals in here because as far as the computer is concerned, these are both numbers. This is going to do the ASCII value of the number 1, and this is going to have the ASCII value of either the digit 1 or the digit 0. The char, 1, 0. If it is, we're going to do number ones plus plus. That look good? Do you see any problems with that, or I guess we can just return the number of consecutive ones, right?
No,
No, why not?
if we hit a 0, it's not accurate.
If you,
So is there a better name for this?
well, you could keep that one
True.
as a number of consecutive ones, but you would need a separate variable
For what?
to keep track of the maximum number of
The
consecutive ones.
largest
Our-
number.
Our best consecutive ones, right? So yes, this is kind of the number of consecutive ones, but there is a better terminology for this, and I would say current consecutive. Right? This is technically counting the current consecutive ones I'm looking at, not the consecutive ones. It's always looking at the current. So when I hit a 0, this is going to reset, isn't it? So that's one of those nice things to keep in mind, is that we want to make sure we are clarifying that it is the current consecutive ones. This is our max consecutive. Whether our maximum is the beginning, middle, or end, no matter where in the string it is, this is the max consecutive we've ever seen, and no matter where oh, Jesus. 0. And no matter where we are in our system, we want to know that this variable is holding the current consecutive ones we're looking at. Else, if we don't hit a 1, what do we want to do? This is when we see a 0, right? What should happen?
Turn current consecutive back to 0.
Oh,
Well,
right away? Okay.
First, we want to store the current consecutive in max consecutive.
Aw. I was like, let's lose our data. We don't want to reset it first. We want to check to make sure that what we have right now isn't our new max, right?
Yeah.
We should check if the current consecutive is greater than max consecutive, we now have a larger max. Current. And then regardless of that result, we're going to set current to 0. That makes sense? So once we get through all this, once we get to the end, what do we want to do?
System out max consecutive.
Yeah, we don't want to return, right? Yeah, S out. I don't think that does it. So system
S out does work.
does? Oh,
It's like
hey, there it
sys
is. Okay, cool. Max consecutive. There we go. Run it. Oh, let's go past the test cases. Let's submit it. Got 2 fails. Any ideas why?
Could there be?
Because it doesn't end with a 0.
What do you mean?
So the max consecutive ones is not
Mhm.
preceded by a 0. I mean, it doesn't end with a 0. There's no 0 at the end.
We're not,
Or
No,
what if our
something-
what if our max consecutive ones is at the end of the string?
is that the edge case?
Yeah, in edge case. Or honestly, what about even this? Let's just run a fun little quick test of 1, 1, 1, 1, 1. What's our max consecutive ones there?
The whole
Five.
thing.
0.
5. But yeah, what we end up getting back is 0, because if we hit the end of the string, we never check to see if our current consecutive at the end of our string is bigger than our max consecutive. When we get to the end of the string, we possibly have been counting more. Right here, technically we have 1 in our max consecutive. We know we don't need to check it, but it could be bigger, right? And so we do need to make sure that after our loop, we say, oh yeah, that the last bit of counting we did is that also that could also be our max consecutive. So we just need to do the same little quick check right there. So that we can just grab this right here. Just that. We don't need anything else. We just copy this, put that in, and that is it. Really, we don't even need to. We can also just system out current consecutive if we want to do. Good. So we submit code
That should
now.
be inside the loop
Why inside?
because it's not getting updated after. Oh,
Doesn't need to be.
okay.
We've done all of it inside. When we jump out, we want to be done.
Okay.
Yeah, as soon as we, sorry, just to confirm it again, make sure we know how this is working. Once we count this one, we make our max consecutive, we make our current consecutive 5. On this case, we then go to, we then jump down to here, we hit the loop, we go back up, and now we have hit all the characters, and so now we're going to drop out of the loop. So where would I put it in the loop?
Well, if you just get rid of the 1 and the else, and then you move it inside of the for loop, you wouldn't have to check it twice.
No, because then on every single item, I'm then checking this. Right?
Oh,
I had
Yeah.
I had a check off every time of 1 hit.
I get. So, but I wonder if we could do that actually. That's interesting because then you're. But, it's a
Yeah, it
memory
doesn't
thing,
see
yeah.
that, but that's just how I did
Yeah.
it.
Okay, that's
Because I was just
fine,
thinking of
actually.
like having 2 redundant, but that makes sense.
It works. Yeah, that actually might actually work now that I think about it. Yeah, we're just going to be constantly updating the max consecutive as we count. So it'll, in the very beginning, it's going to be updating max consecutive alongside current consecutive. So 1 then 1, 2 then 2, 3 then 3, 4 then 4, 5 then 5, 0, 5, 1, 5. That works. Okay, yeah, that actually can be a little nicer on the code. You'll clean up the code a bit. It's a little more on the processing, but overall, yeah, we don't have we have less lines of code. So interesting. Good idea. That should still work. Nope, wait, what did I break?
Because you're still
Oh.
resetting in the loop.
Yep, I am. I want to move this there. No, wait, no.
No, so you need a separate,
I still need the else though
yeah.
for this. Still need that. But the problem is then we'll lose that. Okay, that's
Well, no, so you could do it so that if digit instead of the first stage statement, instead of it being if it's 1, have it be if it's 0, because it's only 0s and 1s.
yeah,
So I had it
you're
so
saying
that the
do-
count went up every time it went through a new character.
Right, so then you would put the increment at the bottom of the loop.
I had
So
it on the top, on the very top.
here.
Yeah. And then every time I hit a 0, that would reset to 0.
This would move up too, or no? Or just this?
Just that. And then I had that as an if else if afterwards.
I can see how
So
that
we-
works.
The
Okay.
second if, yeah.
So, it's for 1, 2, 1. Skips 1, jumps to the top. 1, 1, jumps to the top. 1, 0, skips this, adds that, counts it, doesn't do anything, adds it, so 1, 1, jumps up, it adds 1 to the current, but as soon as it hits it, it zeroes it out, which makes it 0, and so it won't update, and so we keep the 4. See how that works?
Mhm.
And this is another technique of mine. Walk through the code quick. Do something like this. This can be very, very helpful to, especially when you're seeing someone else's solution. Make sure you understand what it's doing and make sure you understand what your code's doing. Program flow is very important for algorithms. So understanding your program flow is a very key skill in algorithms. So if you've never done something like this, it could be why you are struggling with algorithms. These small little tricks that you can do to just understand what's happening, understand the flow of code. Thank you.
Drag racing.
Did that yesterday too.
I'm there with you, Cliff. Same thing happens in my area.
Was that our now? No. So we got that. So yeah, this is a very useful thing to be able to very, very quickly just go through the flow of the code, see how the variables are changing and modifying, so you understand how an approach works. And we've technically seen multiple different ways in how this, just a for loop, can be solved. And as long as you understand each of the ways and how the variables change, this is how you can learn other approaches for future algorithms. And being able to see the flow of code can help you to realize, oh yeah, I can see how that works. It makes sense to me. I can use this later on. Oh, okay, I can see how this is close to working, but not quite. Let me make my adjustments now. So when a lot of you wonder how I can figure out a problem to your algorithm, it's usually because I'm doing this on the side. I'm quickly going through your algorithm, modifying the variables and seeing what the value of the variables are as they go. And then I'm like, okay, I see how this is working. I see how the data is being stored and how the data is being accessed by a what is the word for it? The tunnel vision computer. These are key little skills that you want to be able to start practicing. So don't be afraid of doing stuff like this. Don't feel like, oh, if I do this, I'm the third grader trying to draw a car. No, these are what high-end developers are doing. The thing that makes a high functioning algorithm solver high functioning is because they are able to follow code flow very, very efficiently. Code flow is a key skill for this. Any questions on that approach?
Run the code.
On the code itself. What's that, Jim?
Run the code.
Oh. Why? I'm confused. Makes sense. It should work.
Bless you.
Yeah. Okay.
Wasn't
I
sure if
think
there
I
was
did.
gonna be a
Find
third.
it, but I just wanted to make sure.
I'm making sure. I forgot I didn't run it yet. I hadn't run it yet. That's good. Okay. So that's that one. Delete these, all this stuff here. Now let's look at the split one. So, mouse again. Let's comment out all this for a second. Cool. Now let's take a look at split. So this is going to do string array, what I call, dot split. Oh, no, not n, bin split. And the regex, as we saw, was the 0. So we've seen, again, on our tester how this is going to work. And so in our current example, of bin being 1111101 will get converted to an array of 11111, comma 1. Right? So now I have this array where I have this one and this one. How do I find the max consecutive this time?
You would just check the length of each of the elements, but I have a question.
Go for it.
In the last one, there was a step in there that converted it back. Did you do that and I just missed it? Or no?
What did I do convert back? I didn't convert it back.
Oh, you haven't done that yet. Okay.
And we don't need to anyway.
Okay.
I'm not sure what you mean. We don't have to convert anything back. We just make sure that we're sending the max consecutive in decimal. That's all.
Continue.
No worries. So we got that. So yeah. So in this case, yeah, we're going to loop through this and just check the length of each one of these. And that's going to tell us how many ones in a row are in that grouping, right?
Correct.
That makes sense. So in this one, we're just going to do, again, another 4. So 4. Group in an array.
Sorry, I wrote mine too.
What?
Group for the
Interesting when you find out that when you see someone else use the same variable as you. It's like, oh, okay, I feel more confident in my naming. In that case, and then again, if we think about this, if I had a really long array of groups, how am I keeping track of the longest one?
You're
As
still
I go
gonna
one
need,
by one.
you're gonna need to make another variable to hold that value in.
We still need our int max consecutive, right?
Yep.
Start that off at 0. Do if group dot, and what are we doing for array? how to get the size of an array or the length of an array, or which one is it?
Dot length.
Length.
Anyway,
The string, sorry, the string.
Length.
Is it length for string?
Yep.
There it is, yep. Dot length is greater than max consecutive. Stop jumping around, cursor. Then max consecutive is equal to
group dot line.
length. Anything else I need to do?
Just print it out. Oh, you already did. Never mind.
So I used the same variable name because I didn't comment that line out, but let's see if that works. Eraser enable by now. Seems like that. Let's see if there are any edge cases we missed.
Wow,
Nope.
that's clean.
Just a bit.
Just a bit.
I wonder if Java has this, by the way. So there is a concept in other languages known as max. Max returns the largest item of a collection.
Believe it does, but I can't remember how to use it correctly, but I remember it did have something like, it does have something like that.
I think you have to use that in a stream.
That's a collection. So collections.max. I remember now. Hold on.
Yeah, it's collection.
This is me just being fancy, so don't worry about not knowing this. But is an array not a collection? Maybe not.
No, you'd have to use arrays.
You'd have to use arrays. The collections would have to be a list.
Arrays.max. Oh, cool. Okay. Knowing that don't they do that? Come on, Java.
I don't know if there's an arrays.
I don't think it is, but we can do this thing.
To this.
At least. All right, do that. That's me the largest string. And I can just do largest dot blank. Does so. I also think. Let's see if we can do this. Well, actually, let me do this. Let's find out. No, because it won't actually, I can't dot chain on the end of that. I think we'll do this though. Let's see if Java allows you to do this. Oop, not that. It does not. Okay, some languages let you do that.
Is it because you're trying to store it as a string that's not letting you do that?
No, the max doesn't return a guaranteed object. So that's why I can't dot chain it. That's all.
Oh, okay.
At least I think so. You know, actually, you might be right. Let's find out. I might be thinking that it's not allowing, but you might be right, actually. I'm forgetting how Java works. That dot length. Okay, yeah, you're right. I was right. You were right. Okay, so I could actually do it that way. And that one. Comment out all that. Run it. Yeah, there we go. Could do that. Still not as pretty though. I don't like the fact that I have to convert it from an array list to from an array to a list though. So not as clean as I wanted it to be, but something I do know. And again, this is something for me just being familiar with previous languages. So I'm used to the concept of max and min from my work with like JavaScript and other languages. So I know about max and min just again, because I've solved so many algorithms, so many problems. So I know of this. And this is again, that concept of like where it shows difference between me and you guys. I've done a lot more algorithms, so I know of more methods from other languages, other functions from other computing languages, and other computer science. So this is why I can bring these out of nowhere. None of you I would expect to really think of this unless you've done max or min before in a collection, knowing that that there is this concept of in an array or in a collection that you can pull the maximum item out of it or the min out of it. Now, how this is working is pulling the max because it's just pulling out the largest string in this case. That's all it's doing in this case, pulling out the largest string, which is what we want. We want the largest grouping of ones. That's why this works. Interesting stuff, right? So you've seen several different variations of how we can simplify this code and make it better and better. And you've probably seen the associate level solution, the junior level solution, and the senior level solution, right? And really the difference between all of these is just knowledge about computer science and knowledge about the methods. These more unique methods that have nothing to do with how a human would solve the problem, but how after I solve the problem as a human, how I can now apply my knowledge of computer science and how computers work to solve it even more effectively. Starting from a very aggressive loop that has to touch every single item in the array after converting it over. So you can think of this as an O of n, as an O of n. However long our binary string is how many items we're going to touch in that array, right? If our array ends up being 100 digits long because I gave it a, let's see, let me go ahead and make this number a little bigger. There we go. See how we're getting larger and larger, right? And so now I have to touch every single one of these digits one by one. Right. That's a perfect face for this. Yep. Thank you for that, Matt. Or did that not in recording? Dang it. So I'm going on Matt's face and it's not there. No one's gonna understand what I'm saying. What was someone else saying?
I was just saying the constraints was the 10 to the power of 6 was the constraint of the algorithm.
10 to the power of 6. 1, 2, 3, 4, 5, 6. So that I think 9. Right? Yeah. So I think that means it's 6, 0. So that should be the maximum. Still a pretty decent sized number. Right. But converting this, we can see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 touches in our split method. So we do a split without the max system. We just did a split. We have 11 touches in this array versus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 24 elements. So we've easily cut it in half, almost. In our max item, it works even better. So we don't have that looping structure in there anywhere. We have the O complexity of how max works. So you have to check what the O complexity of max is and the O complexity of 2 array. So it is possible that actually might not be more effective if the O complexity of like 2 array is not effective or not efficient. So it may not simplify the O of the complexity of anything, but it definitely looks nice in the sense of just simplistic code, of small code. So that's kind of the thing here. So again, all I'm showcasing again here is that the basic solution of the for loop is the most easily followable and understandable. The biggest challenging of this thing is just to be aware of that concept of counting as you go and of running totals and keeping track of something. When you do, one of the biggest things is as you do this stuff when you test out your own code and you test out your process, if you start counting out loud certain numbers or speaking certain numbers out loud, you might want to think to yourself, oh, those are variables. I'm trying to remember those numbers. If you find yourself writing numbers down on the side as you're trying to solve a problem, think to yourself, is that a variable? Did I just write down a variable? Did I just save that information for later? That might be a variable. I need to keep track of that. So being aware of how you work through a problem to know what you need is one of those key items. And then again, understanding algorithm flow. knowing how each line of code works and how your variables are modified as you go through the program. This can help you to solve algorithms. And then as you solve more of these, again, you'll be introduced to more concepts. And then after you solve one, again, as I've said before, once you solve the problem and you've solved it, you're okay now to go to see other solutions now. You can go look at other solutions and see what people have done. So you can see, maybe you can learn about max or min or split. Missions, maybe? Oh no, leaderboard, dang it. Yeah, leaderboard. Once you solved it, you can go to leaderboard, click reveal, and be like, yep, it's fine because you've already got your score. So even though it says your score will be counted with your progress, you've already got it. So there's just saying any new ones. I don't care anymore. So I'll do that. And now I can look at those solutions. I can look at mine's top of that, but I can look at Allison P solution on Java 8. And see that we did the for loop. All right, cool, good to see. I'm feeling a little better of mine. I can see, it could introduce me to maybe some nice variable names. I can see a 2-char array there. Let's take a look at this person's quick. Oh, that was not Java, was it?
Yes, Java.
What is
Oh, it
Java?
is.
Yep, they used very fun variable names.
They
They
did
used
the
a while
while
loop.
loop instead.
Interesting.
That's a way to do it.
Interesting. It works, but very interesting to manage the I yourself. That's a little odd to do. I don't like doing that. But again, it's good to see that it can be done. I want to see if anyone has max or min or split. Like split, max, or min. One of those. Split or max. There it is. Oh no. Another while loop. While num is greater than 0. Num, huh?
Oh, it
What are
looks
they
like
doing here?
I think they're making their own binary.
I
Yeah.
think so. Yeah.
Yep.
They did.
Modulo
Yeah.
2. Yeah, absolutely.
Yep. They're making their own. They're making their own number. All right. They're building it themselves.
And they're counting it as they're building it. Ooh.
Yeah. Interesting. So crazy. All right. There you
That's
go. That you can look at and see how that works. Another one. That was done. That was a Chinese one. Interesting. This
They're
one.
building out theirs too. Like I built
building their
mine
own.
out like that.
Interesting. The one
I built
downside
mine
I do
out.
say with what is it? HackerRanks versus either Code Signals or Code Kata, I think it is. Those two. Is that you can't, that people don't get to vote on solutions to say if they're good solutions or not. With Code Signal, people can actually upvote solutions so that you can see a top solution. So I will keep that in the back of your mind that Code Signal does provide better after research. So when you're done solving it, you can go into Code Signal's leaderboards, and their leaderboards are actual leaderboards. People can rank or upvote what they see as good solutions or impressive solutions. And so usually at the top, you'll see the best solutions of certain languages. And so you can see really interesting solutions. It's how it's actually how I learned about, we've talked about before, you remember the collection concept known as a set.
Yep.
We talked about that. Data structure sets a collection of unique elements. I learned about that concept in JavaScript through Code Signal solutions. Seeing a solution to one of the algorithms I worked on, didn't use a set. I actually managed and created my own unique collection by checking to see if the element existed or not already, using index of and all that fun stuff. And then I looked at the solutions like, what is a set? And I looked it up, I'm like, oh, that's useful. I don't need to do it myself. Kind of like what some of you guys did with the building your own binary stuff. By looking at these solutions, you could realize, oh, I don't need to do it myself. I can use this to binary string. Because I think our first person did that, didn't they? Yeah. So like an example, like I think Matt and Jim, you said you both did it, right?
We did it out. We
Yeah,
didn't do that.
yeah. I built.
So as soon as you
mine
did it, you go to solutions, you go to see it here, and be like, oh, okay, that exists. Good to know. So some good stuff. This can be very useful. Once you've solved it yourself, feel free to go through some solutions and see other approaches. You can see other methods that
Interesting.
you don't know about.
The other one was interesting. She used the ternary also.
Feel free to look through them. So once you solve one, especially one that feels like it's an interesting solution, you feel like there could be more ways of solving it. Spend like 30 seconds, spend like just a minute or two just looking at one or two solutions. That's it. Don't spend too much time. Just spend like click like 2 or 3 of them and just take a look and see if there's anything cool that you can learn about. All right. I said the 2 other solutions I gave you guys that we were able to come up with for this one is entirely based on just knowing the methods exist. Understanding split, being familiar with split so that it pops into your head, And for me, by knowing max and understanding how max works after using split, after seeing view a split, I remembered, oh yeah, max is a thing. I can just pull out the largest element out of a collection using something called max. I wonder if Java has that. I know like JavaScript and Ruby had it, and Haskell had it. Maybe Java has it. So, any questions on this one?
God, that was super helpful.
Okay.
It's funny looking back at my own code. I feel like I was very close to at least one of the loop solutions. I was just a step away.
Awesome. So now from here, everyone hopefully again will be able to move forward through day 10 now and go into the other ones. Again, if on any of the days it goes, if we start getting stuck again, use that submission form. Submit that it's been kicking your butt. Again, try to reach out to at least one classmate to see if anyone can give you like a tip. We'll keep solving them. What time are we at? 8:30. Let's see. What are the two other algorithms I have right now in my listing? Two other algorithms. See what I enter for the poll, so that's fine. What would I rather do? I would highly recommend that as I do this, if you solved it, if you solved this one, you might want to think of doing the other one. So it's just out of the two algorithms I give you, if you solved one of them, maybe don't pick that one. But again, I can't force you. So yeah, unless you don't like your solution, you think, oh, maybe there's a better one. Choice. This one again, that way you guys don't know what people are picking. This is code signal actually, so that's fine. So you guys, I think I assigned this to you guys, so everyone knows this one. So yeah, that one. That is code signal technically, but those are the two that have been submitted. Those save.
What if we solve them both?
Pick the one you're most interested in then. And seeing a walkthrough of it.
Oh,
House
co-hosts
robber.
cannot vote apparently.
Co-hosts can't. Can I revoke your opinions? Can I revoke your
Privileges.
I don't think I can revoke it, but what I can do is do
Where are we
this. Hold on. Ending
I
the
can
poll for a
DM you
second.
my vote.
Go for it. And again, I don't think it matters. I already have 8 votes. How many people are here?
I see them and
Oh,
Are you gonna give us the answer?
what? The solution or
The
the
solution?
poll?
No, I mean,
Potentially.
yeah. What if
Well-
we don't? Like, I just want a hint.
We could try that.
Okay.
I can give you some. We can do that because we only have 30. We're actually at 8:36 already. So in this one, we'll do this one actually. Yeah, we'll do kind of a understanding of the problem and go through a couple hints on it without actually giving a solution.
Okay.
To that. And you know what? Yeah, that's not. It's 10 out of how many people? 1, 2, 3, 4. How many people are in today? I don't have participants open. Where is that?
There's 16.
17. Well, yeah, 16.
16. So
Yeah, Cliff is 0.
11 out of 14 participated, with 2 of them being, so we have 5 people have not voted yet, if you include the 2 co-hosts. So yeah, there's no chance for the other one to win because it was a pretty big landslide there. As you can all see, we pretty much had a almost unanimous selection. If I let the other 3 vote, it might have been unanimous, but looks like we're looking at house robber. So
Highway robbery.
pretty much. Master Robber ran away with it. So not by me. Like I said, we'll do this more of a just a tip system. So we'll come up with some tips, some advice, and so that. And again, what we can do then is at next week, if people still haven't solved it, if you want to resubmit this for a solution walkthrough, we can do that. But let's give everybody a shot on this one. So
Cliff, do you think some algorithms like this, if we want to have like hints, if we do like group code, just to see like where we've gotten up to, so that we were like not given the answer, but we're all working towards like maybe where we're all collectively stuck?
yeah. So the first one I wanted to do a walkthrough of it, just because that one is, I know that one can get a lot of people stuck. What I am looking to do next, later on, actually, on a lot of these, is to do a split breakdown of understand the problem, give you guys some tips, do a 30-minute break where you guys actually work on the problem yourself to see if the tips actually let you guys actually solve it, and then we come back and either decide to attempt it as a group then, potentially. If there are some people that are still unable to solve it. Because again, what my goal of doing this, by solving that problem, I was with you guys, I was able to show you the other variations of solutions. And then if we never solve it together in the class, you don't see those. And then max, for example, especially the concept of collections.max is never introduced to you. And so that's a part of your language that you never know even exists. It's not even a tool that doesn't even exist in your tool belt until you somehow stumble upon it on your own. And so that's why I am hoping to, at some point with these algorithms, do work through some extra solutions. You see those extra solutions, you see those other functions that you might not be aware of. That makes sense? So I am thinking for next, apparently Monday. So based on how the poll is currently going with how the schedule is going to change, Monday will be algorithm day. So most likely on Monday, we'll do something like that, where you guys will come in, we'll look at the algorithm from the submissions. Maybe we'll do another poll again where you guys will vote on which algorithm we look at. We'll do some tips on it. We'll kind of review it, give you tips, give you some advice, walk through some of the potential approaches to the problem, let you guys break out, attempt it yourself, see if you can actually come up with the code to actually solve it. And then we'll come back and actually look at some solutions that classmates came up with, and even some additional ones as well, so you can learn some new methods. No matter what, we're not going to solve together in class that many solutions. There's enough algorithms for you guys to find additional challenges, even if we solve a couple together in class. So don't panic too much that we're solving some that you haven't solved it yourself yet in class. But I will make sure you guys have the ability to attempt each one before we actually solve it. Make sense? Sound good?
Mhm.
Cool. So that's what we're doing here. We're going to do that this time. So we're just going to do the introduction and tips and kind of overview. In, and then where was this one? Where did we find this one? This was under.
It's in chat.
You got the link? What chat? Zoom chat or Slack chat?
Zoom chat.
Ah, thank you, Sergio. Go.
It's pretty straightforward.
All right. So since everyone picked this one, I feel like you guys are probably familiar with it. Is there anyone here not familiar with this problem yet?
Me.
All right, take a second and read it then. And let me double check, make sure I remember this one. So I'm actually gonna read it quick too. All right. So can someone in your own words explain the basic gist of the problem?
Yeah.
based on what I could read there, it seems to me that we have to add the numbers in the array that are not next to another number. If that makes sense.
Okay.
We have to add together every other number.
All right. Anybody else?
We have to determine the greatest possible amount of added numbers in the array without adding two numbers directly next to each other.
All right. Anybody else?
Pretty much it. You just gotta skip every other number.
Oh, I think what Matt said made more sense than just skipping every other number.
It's not
Yeah.
as
Yeah,
simple
yeah,
as
it's-
skipping every other number.
I wish it was.
There are test cases that go against that.
Counting any numbers that are directly next to
Yeah,
each other.
I keep thinking like at the end of the array, what's
A
gonna
subtle
happen, you know what I
difference.
mean?
Well, put it simple here. Let me just showcase it again. This is where it's good to kind of in your head kind of run through a couple of just like scenarios to make sure you understand like the concepts. And this is where it can also be helpful to do this with another person. Because then you can ask each other, what do we think about this? So let's see what people think. What do I do with my pen? Oh crap. Oh, I didn't put it back. Okay, cool. So, and so in the example, of course, they gave us, and I'm not on a pen mode. Back here, where's the annotate button? Here we go. Annotation thing.
You just comment
there it is.
underneath.
There it is. Yeah, that. Again, it's easier for me to do this. Like this, we got 1, 2, 3, and 1. And what's the fun little phrase to say? What are the best houses to rob here?
1 and 3.
Right? Yeah, these ones. Which looks like it's the every other. So yeah, if we do 2 and 1, I'm not gonna get anything. But theoretically, am I allowed? Is this a valid option? 1 and 1.
Yeah.
Yeah.
It's not gonna get me the money, is it? So technically, if I wanted to say if I had a street where I had 9, 3, 2 and 3, and 9, what's the best option now?
Yes. First and last.
9, right? Yeah. Let's look at this one. So in this example, they gave us 2, 7, 9, 3, and 1. The best scenario here is
2 and 9.
2, 9, and 1.
2, 9, 1.
2, 9, 1.
2, 9.
So here's an interesting. Now this is where just asking random questions can help you to understand the problem better. Why would I not want to go after 9? What would make me want to choose one of these over 9, other than one of these being larger than 9? Because we know we're going for 9 because 9 is the largest. As a human, again, weird saying human as for robbing. The reason why we're going after 9 as a human is because it's the largest number, so we're going to start there, right? In our mind, that makes most sense. Why might I not go after 9 initially?
Because the combination of 7 and 3 is greater than the 9 individually. And if we take the 9, we can't get either the 7 or the 3.
Right. So if my thing here was 2, 9, 1, let's say 7, and let's say 6. The 9, 10, 11, 12, but then 7 and 6 is
13.
13.
so now 7 and 6 is our better.
Yeah.
Right. Again, though, if we do fun little scenarios to make these things interesting.
I fell into that trap then.
What?
I went after the largest number for the most part.
So this is that concept again. Let's say again, try it. Again, it sounds weird saying this. That's what's
So I have
doing
a-
these kind of scenarios.
So when you're running through this, would you not initially always start at the first index?
Potentially, again, you could, but not necessarily. You could start there, but not always necessarily. It may not be worth it to steal from the first index. But that's the next thing we have to figure out. Like, we know we're jumping to the middle on this one because it's the largest number, but what are once you see the correct solutions, how can you figure that out as a computer when going down the street? So let's say, yeah, you're driving down the street to pick the houses, and for some reason, each house, you have your superpower is apparently a villain power. You can just, by looking at the house, tell how much money they have in it. Really odd scenario, but you just, yeah. So as you're driving down the house, as you're driving down the street, you can see on each house, but only as you look at that house can you see it. Once you look away, you no longer have it. So you have to either write it down in a variable or memorize it in your or drop it. And so this is a great kind of imaginary thing. And this is sometimes how I can help myself to think of solutions is by imagining the most outrageous way of forcing myself to think like a computer. And so in my mind, it's me, I'm in my car driving down the street. There's houses on one side of the road. And as I drive by each house, I look at it, the amount of money they have pops up. As soon as I drive past it, the number will go away, but now I can see them. Because that's how I'm going to iterate through this array, right? I'm going to iterate through it. I'm not going to be able to pop around and jump around in the array easily. Could I write something that allows me to jump around a little more? Of course I could, but that's not going to be as easy, right? And so those are the things we have to keep in mind. How can we learn these? How can we, as a computer going through an array, how can we analyze information and find what we need to find and make our determination? Now, one thing I could do, again, this is just the way to keep thinking of analogies and stuff. What I can do, of course, is I can technically have me and another person with the same exact power. So me and let's say Matt are going down the street together. And so we both have the same power. So I'm going to stay here at house 1, you go down and let me know what the other numbers are. I'm going to stay here at the first one. As soon as you go down all the way, come meet me back at the second house. You know, your I and J iterations, your dual loop iterations. So as soon as Matt makes it to the end, he comes back, I move forward to the house, I know mistake, all right, go again. And now let's do some more comparisons. So does that help us to make a plan better, right? Of course, thinking about that, and one of the benefits of me doing this weird analogy is now I have to think about, well, yes, this works. It does increase my cost because now I have to share whatever money I make with Matt. So it can help make me very much aware that what my current now approach is going to be more costly. I might need to do this in order to figure out the solution. So be weird with your analogies, be weird with your scenarios to figure it out. One of my remembered issues when I did that code signal challenge from not code signal, code gym challenge from Google. One of my problems again was like this infinite bathroom with toilet stalls, and I was literally writing toilet stalls on a board trying to think about people using toilets. It was the strange thing, but eventually I figured out the solution. It was not a good solution. I found out later though. Just a heads up. There was a much better way of solving that problem, but I did get a solution. And so be as crazy as you need to in approaching this problem. But be aware, the main thing so you might need, in this one, you might need multiple approaches for it. And I'm trying to think, was there any tip I can give to try to get a more mathematical item? Not necessarily. What I can say, how can I give a tip on this one without giving too much?
I'm confused. I don't know how you can, if you start your index
there is the
not
brute
at
force
1.
first. Yeah.
If you start your index not at 1, when it runs through them, it's going to do that for all of them.
Yep.
If you started at 1, it's going to do that for all of them. So you can't pick and choose which ones you want unless you're
kind of
going to write a scenario for, 3 or 4 of them, and you don't know what each of them is.
Like I said,
that's why I said, aren't you not always starting at 1 while starting at 0?
As a computer, yes. As a computer, you're always starting at the first index. Yeah, it's not possible as a computer just kind of jump around an array, unless you know the length. And I guess you could. Okay, correction. You can jump around an array because we know the length of the array. You could always just start in the middle and then go left and right and break down that way. You could also try converting this into some of the data structure that allows you to then navigate differently. You could try to convert this into some sort of graph system of some kind. Would I recommend it? Not off the top of my head. Doesn't make sense in my mind. Because again, one of the things you can do is by being able to mark off cost and gain. So for example, in this one here, we did a 2, 7, 9, 3, 1. One thing we have to be aware of is for every one we pick, we also lose. So when we picked 9, we had a gain of 9, but what did we lose technically?
7 and 3.
Which is a loss of 10.
10.
Yep. So this one has a profit of 1. with the 2, we have the 2, which is a gain of 2, but a loss of what?
7.
And with the 1, same thing, we have a gain of 1, but a loss of what?
3.
3.
So that was something I started looking into. It's not a perfect system yet, because it currently doesn't seem like picking the 2, the 1, and the 9 is being good. But let's look at the other ones. Let's do this actually. I'm lining these up bad. Hold on. Do that there, this here, that there. That there. Let's fix this bit. So gain of 9, loss of 10. This is a gain of 2, loss of 7. The gain of 7, but a loss of what?
9 and 2.
It's
Loss of 11.
So this is a gain of 3, but a loss of
9 and 1.
10. It's a gain of 1, but a loss of 3.
3.
So any pattern here. So if you do this, this is going to be a what? Loss of 5. This is a loss of how much?
4.
Say
Loss of 1.
this is a loss of 7. This is a loss of
2.
Still, I'm not really seeing the pattern I was expecting to see.
But you're adding like losses between this, but don't you? But you still have to take an effect that account that you can't use like these
Right.
because you have
The
to
loss is because it locks them. And that's something that's, I'm trying to remember, how do you track that though? We know that it's the gain of 9 with a loss of 10 because it locks these out.
Oh, okay. All right.
And so somehow you then be able to know that everything else on this side could be gainable, right? So
Okay.
with this case, now that I've done this, I now know that I've already calculated the loss of the 7 and loss of the 3. So now the 2 is no longer a loss of 7 plus 2. It's now just a straight up gain. Same with the 1. The 1 is no longer a loss, a gain of 1 minus 3 because I've already calculated that in the 9, right? So since I've already calculated in the 9 that I've lost the 3, the 1 is no longer losing the 3 as well. The 1 is a straight up gain. So again, thinking of this is me again, this is brainstorming. I have not come up with a solution yet, have I? But I'm learning things about the data, right? And I'm approaching them, I'm just throwing numbers around to see, can I find something that I can grab onto? Is there some sort of logic here that I can grab onto to help me make my decision, right? That's what I'm trying to do here. I am just grabbing at things, trying to find what I can do. Now, once I know this, then I'm like, okay, well, yeah, then I have a +2 plus and +1 here, and then yeah, -1 total, but my total overall there is a +3, which is fine. So all this interesting. So there's that, and then I can try to do the same thing here on the 7 side. So let's say we're gonna grab the 7. So grab the 7. So it's a +7 -2 and a 9, which is 9 to 11, which is the -11. So you have a loss of -4. So it's -1. And now I know I can use a 2. The 9 is also out. So the 3 I could grab. The 3 is a gain of 3 with a loss of 1, gain of 2. The 1 could be grabbed. So the 1 would be a gain of 1 with a loss of 3 or a loss of 2. Which one's better to grab?
They seem to cancel out.
No, which one's better?
Oh.
The gain of 2.
Yeah,
Yeah, the
I
gain
would
of
grab
2.
the 3, right? So this could be a way of hinting at which ones I should grab down the line. I can look at the optimal grabs on each one. If we look back here again and looked at these before, so just put the numbers back now. Let's think about this for a second, actually. I think I just thought of something. So loss of 7, loss of 3. This is going to be loss of 5. This is a loss of 2. Out of all of these, which is the optimal to grab? Even though they're all technically losses, which one's the best?
Loss of
Loss
one.
of one.
Right, yeah, this is gonna be this is gonna give me the most for my grab. So I could start with the 9. Like, you know what? I'm gonna grab the 9 first. So I grab the 9, and then on the any other number, so that means the 7 and the 3 are locked, but that also means on any numbers that are losing the 7 or the 3, I can now remove that from my options. So this one now is no longer losing that. So this is now only a +2. We know this one's locked out, so that's a no-go. I can't grab that at all. This one's a no-go, can't grab it. Then -3 is no longer -3, so it's a +1. What's the next best item to grab?
The +2.
All right, so we'll grab the +2. So we grab the 2. So now we have the +2. Didn't affect my 1, so I didn't change it. So is there another best item I can grab?
1.
I can grab the 1. So this led me to what I wanted, right? This led me to the optimal solution. Can this process lead me in the other one? Let's find out. Let's just play with it. So we got the 1, 2, 3, 1. We know that the optimal is this guy and this guy, right?
Mhm.
We want to see if our solution gives us that. So the 1 is a gain of 1 and a loss of 2. This is a gain of 2 with a loss of 4. The gain of 3 with a loss of 3. This is a gain of 1 with a loss of 3. The results here are loss 1. No, right? Yeah. This is a loss of 2. This is a 0. And this is a loss of 2. Which one's the best one to grab if you look at those?
The 0.
So grab the 3. That means this is no longer available. This is no longer available. The
And we
1
get 1. Uh-huh.
no longer has a loss, and that is now a gain of 1. Which one's the best to grab?
The 1.
Seems like we might have a process, huh? This might work. We would definitely need to do more testing, right? This would be my first now point of attack. I'm going to let you guys in a secret. I did not have a solution for this one when I sent it to you guys. I don't always have a solution for them when I assign them to you. I want to learn from you guys too and see what you guys attack. And I do like solving them myself at times as well. So
How
actually,
recently did you formulate this then?
today, as we were doing this, this was actually real-time problem solving. So I wanted to do this with you guys to show you a potential approach that I would go through.
Wow, that's cool.
Running through numbers, just trying things, seeing if I can find any sort of pattern or logic or approach. So now what I would do is I would come up with some other more edge case like scenarios. You know what? Let's do the one we came up with earlier that said, why would we not pick the 9, right? We came up with this one right here. Let's think about it. It was the 2, 7, 9, what was it? 6, and then 1, right?
3.
This came up with, hold on, I know this was the other solution where this would actually be the better result, right? It was 9, 10, 11, 12, but 7 and 6 gives us 13, right?
Mhm.
So we would actually want to rob these two in this scenario, correct? The weirdest statement again. I want to rob those 2 houses. So in this scenario, I don't want to do the 9, even though it's the highest number, right? Let's see if our logic that we just came up with actually tells us that. So the 2 is a gain of 2 minus loss of 7, because we lock out the 7. We pick the 7, we gain the 7, but we lose the 2 and the 9, which gives us minus 11. If we take the 9, we get a gain of 9, we lose what? What's 7 plus 6?
13.
13. If we take the 6, we lose the 9 and the 1, which is a loss of 10. We take the 1, we get a gain of 1, but a loss of 6. Our totals are a loss of 5, a loss of 4, I think, right? Yeah, 4. A loss of 4?
4.
4. A loss of 4.
4.
And a loss of 5. Interesting. That is not what I expected.
Hey, did you say 9 plus 6?
Huh?
9
7
plus
and
6 is
6.
15.
7 and 6. Not
Oh,
9
7
and
and
6.
6. Oh, okay.
7
All right.
6. Yeah, that's 13 there,
That's
right?
13. No, that's
9,
right.
10, 11. 7,
Yeah.
8, 9, 10, 11, yeah. 12, 13. God damn it. I
Yeah,
don't
this
know
could
if I-
pick any of them.
This one isn't perfect, so it's one of these guys now. But it definitely is, it seems like it's telling us that this is the area. So if I look at this though, so here's the one thing for this edge case though, if I'm thinking about it. If all three of these are optimal solutions, what is my best bet? Do I pick the middle one?
No, you pick the outer two.
Right, this is telling me I should probably pick the outer two on this case, right?
Yes.
Which is exactly what we want to be told to pick, right?
Mhm.
So if we have a three-way tie, we know what we need to do. We pick the outer two, which will lock these, lock these, lock these, and tell us, hey, that's what we were looking for anyway, isn't it? So it might still work. We just found an edge case that is very scenario. So more testing needed, but it still kind of worked.
Wow.
Not as expected, but it did kind of work. So this might be the way to look at it and try it. So that is my tip for you. This is how, and I'm going to actually attempt this myself too for Thursday. I'm going to try solving with this process.
Sure.
Now the game, of course, is how do I figure this out in code? All right. So that's the next biggest challenge, of course, is what is the data structure for this that makes sure I can store and access this data correctly. All right.
Mhm.
Any questions?
currently.
Now, Leah, you were the one who said you didn't want me to solve this. How did this look to you?
I thought we did house robbers on code signal.
It's the same.
That's where we are.
Well, you're on
Leak
leak
code?
code, but
Oh, I am. What the hell?
it's the
I
same
clicked in
thing.
Code signal.
It
Oh,
is the same one?
Sergio sent me a
Sergio's
link.
link.
Oh, okay. I went to Code Signal, but then yeah, somehow I forgot that. Yeah, Sergio sent me a link. I didn't realize.
It is,
was
oh
Leak
yeah,
code.
it
Okay.
is the same problem.
Okay.
Oh, I didn't know.
Didn't realize that.
Leak code was
I don't know
the
if you
first
said
one that
anything,
came up.
Leah, but because I didn't hear anything.
So I took a look at test case 24 from Code Signal, and the issue I had was that the logic needed to be smart enough not just to take like the which best combination of alternating numbers would give us the highest
Correct.
outcome, but it would need to sometimes choose indices that were two indices
Yeah.
ahead.
Do you
So-
remember that one at all, or an
Yeah, I've got
example
it.
of one we could use?
It's pretty big.
Oh, we'll see how big. How many?
It is, so it's 13, so it's 14 integers, and they range from 55 to 232.
Oh, goddamn.
Well, I've got it written out. Do you want to see it?
Sure, let's share your screen. Let's stop sharing. Maybe we can just pull out a portion of that just to test. Can we detect that that gap is what we should be pulling from? So see if we can pull out a smaller version of it. Oh, you went and doing trees too. Okay, cool.
So this was my thought process. It works for this specific case, but I don't know if this could be written in code to work for other cases like this one.
Gotcha. So where do you want to do the jump around? What is the optimal we're looking at?
You mean the solution?
Yeah.
So, all right, so my thought was take each
No.
number.
Sorry, what is the expected output is what I mean.
The expected output is you start with index 9. You want index 1, 3, 6, 9, 11, and 13.
So that. I wonder if we pull just this grouping here, if we can test that would be the same result, that those would be the optimal grabs. And that way we can detect this, see if our current solution would evaluate this gap. Correct.
Okay.
Let's just test that. So 185, 5, 232, 9, and then I ran out of space because, yep, never mind, hold on, I can move all that. I can't move. Dang it, let's try again. Hold on. Actually, no, I don't need to write it there because it's all over there actually. That. Let's do that. As you said, the optimal solution is this one, and this one, which means I goofed up my gapping. So gain of 185. Someone want to get a calculator out. 5.
Probably a simpler one of the tests that shows the same example where you have to skip over 2 instead of just 1 every
If
time.
someone could come up with one, I'd like that.
I mean, I found a very simple one. It's just 1,
Oh.
3, 1, 3, 100.
1, 3, 1, 3, 100.
Yep. Because you want to skip
Yeah.
over the second 1, 3 because you want the first 3
100,
and the
yeah.
100. So
That makes
you
sense. Okay.
want 3
Much
and
nicer.
here.
All right, so yeah, in this case, we want the 3 and the 100, correct? That's what we're stealing from. So let's see if this works. So gain of 1, loss of 3, gain of 3, loss of 2, gain of 1, loss of 6, gain of 3, loss of 101, gain of 100, loss of 3. So that means our result, of course, is a loss of 2, a gain of 1, a loss of 5, a loss of
99.
98,
98.
and a gain of 97. Huh. Which one should we grab first?
Gain of 97.
Well, I think we'll steal this one first. And that locks out the 3 here. Means this 1 is no longer doing a loss of 6. It's now doing a loss of 3. Means that it's reduced to a loss of 2 now. We have loss of 2, gain of 1, loss of 2. Which one's best?
Gain of 1.
Gain of 1, which is our 3 right there.
Okay.
Seems like it might work still. So far hasn't been lost. Now, again, is this the most effective way of finding it? I don't know yet. And again, I haven't figured out exactly yet how I would track this information, but it does seem to be it does seem to find us what we want. But how do we calculate that in a way that's effective is going to be the trick. And I can't say that a graph or tree-like structure couldn't be useful, so we can easily change our loss and gains to certain houses and stuff. So there most likely is a data structure we need, or at least maybe an object. So I could throw out an object-oriented solution where we create an object that can store the information for this stuff, so we can easily adjust things. Might be useful. All right, so just be aware of that. That might be important. Yeah. Any other questions? So feel free to attempt that one. That one, again, we don't have algorithm day till Monday, so take your time on that one. That can be the challenge one for everyone. I'll leave that one open for you guys. If we do want to later, we can always resubmit this one for a review in class to see what people have come up with, to see where we are close. So that can be something we bring up again next week if people want to. But again, my goal in this one, again, just to showcase that when you approach a problem like that is very, very tricky, just start writing out things and just seeing what sticks. What can you find? And did I at any point there start digging into data structures right away?
No.
No. I'm going to let the logic tell me what the solution is and then find a data structure to utilize that logic. I now can see a potential logical deduction system. So I found a deductive system of how can I evaluate those houses to figure out which one is the next optimal item to grab. So I found a way to evaluate which house is the optimal house to rob. But now I just need to figure out, okay, what data structure can help me to optimally figure out that data? I could brute force it first, but that's I can safely say that based on what I'm writing there, it seems like that could be very difficult for a large street, right? That's probably not going to work for a large street. So later on, I do need to figure out what is the optimal way of finding that information. But overall, we've at least found a pattern and some sort of logical deductive reasoning that we can use that a computer can do. All right.
I have a question.
Go for it, Jim.
If you had this on a hacker, if you had this in an interview test, this particular problem, what would you have done right now that would have cut this all the time out that we have been working on that? Just to be able to write down, say, okay, I've got some type of mental thing of how I'm going to get that done.
first off, I wouldn't have been trying to explain everything I
No,
was doing
no,
there.
no,
So
no, I realize that. But no, but you just came up with the logic now. It wasn't like you already had beforehand
No.
knowledge of it. That's more
right.
of a-
So all you saw of me testing things out was in real time, me trying to figure it out while still also pausing to explain my thought processes as I wrote these numbers. So
yeah.
in a real situation, everything I was writing down, I would have been able to just write down and just try things without having to explain as I go. So what we did today would probably have taken me half the time, if not a quarter of the time, to actually come to this endpoint of finding that logical deductive reasoning process, you know?
Yeah.
Or he would have went to
so-
the next one to maximize
That
the
too.
amount he could do.
Yeah, that too, of course. If one like this, if I'm like, yeah, a couple minutes and I'm like, I have no clue yet, I would force, my first thing, of course, would have been I would have looked at all the problems first and picked out the ones that I could easily see a potential solution right away. I probably would save this one for last, honestly. But then approaching this one last, yeah, I would definitely have come up with this process a lot quicker. And then if no data structure pops into my head instantly, I go brute force it first, just so I can pass some of the test cases. Brute force it, get a couple test cases passed, and then possibly while I'm going through the brute force, I might think of a data structure that I can add once I get a couple test cases passed first, because that is key. Get test cases passed. Let some of them time out, and so you don't get the points for those, but at least since you solve a bunch of them, you can get a bunch of points right away, and then whatever time you have left over after you've solved all of them, you're going to come back and be like, all right, now is there a data structure or where are my choke points on this that I can then cut back on? So in an interview, unless I can easily pop into my head a data structure or some sort of process is going to make it faster, I'm going brute force just so that I pass some test cases.
Okay.
All right. But I 100% would take the time to draw this out like we did. I think we started working on this at 8:45. It's been about 30 minutes, but like I said, I also had to explain and walk you guys through what I was doing instead of just freely drawing blindly without having to speak at all. I easily would have shaved off half the time on that to get to this point.
I agree with that. I'm just no.
Yeah,
I agree
it
with
feels like it takes a lot longer than it does. The main thing though is just don't go when you're in an interview thing. The main thing to avoid is to be stagnant staring at your code, thinking that you're thinking through a solution. Make sure you're drawing, writing, doing something active in your thought process. That helps you be aware of the time that's going, and it can help to make sure that you're thinking of something. Unless you are someone that actually can process in your head and not forget stuff and actually go through quicker, because I will argue that yes, being active and drawing things can slow you down because you can only think as fast as you can draw. So do be aware of that. But unless you can do it all in your mind because you have a calculator mind, don't rely on that. Unless you know for sure you're someone that can do that.
Guilty of looking at the code. I mean, if I stare at the code hard enough, I think
you think it's going to jump at you. It doesn't. It does not.
The moment you said that, I'm like, I've been there so many times. I'm just like looking at the code, and I'm like, yeah.
That entire time we were doing this, I never once stopped drawing or trying something, moving numbers around, looking at numbers, evaluating different scenarios, trying to think of like, why would I do this one? What can I do to help me determine that this is the best one to rob? At all times, I'm asking questions. And I'll even, if it's a challenging one, I'll do it out loud. I will ask myself these questions out loud to ensure that I don't do the blank stare, that I don't stare thinking that I'm thinking about the problem and just going in circles or letting my rabbit hole happen, letting a little bunny rabbit grab my attention. So in challenging ones, it can be very key to make sure that you're always thinking about something new and a new approach. Don't let yourself get stuck in the just stare and hope that it pops into your head. It probably will not. Could it? Yes, but it's not a reliable concept. But it's something. What I will also say though is, as you're doing that, don't be afraid to pivot completely when you're doing that process. Just because you're liking your current idea doesn't mean you want to spend 10 minutes on that one idea trying to make that one idea work. If you spend like 5 minutes trying the same kind of thing and not getting anything yet, go for a weird random pivot and just see if you get something new or if it reinforces your original idea. If the random pivot reinforces your main idea, go back and keep working on that. But sometimes that weird random pivot can show you that you were nowhere on the right path. This is the better path. That makes sense? The first thing we asked about ourselves was just, why would we pick the other two houses next to it? Oh, because they might be equal to more. So let's add up the pairs on the side and see if we pick those. Not necessarily was the best option. So I had to pivot and be like, all right, well, let's see what the gain and loss of each item is. And at first it looked like it wasn't going to work. I'm like, all right, what about this though? Can I use? Oh, well, I can still decide which one's the better option based on looking at all the bottom results. So it took me a bit to get there, but as I pivoted a bunch of times, I was able to reinforce that original approach of gain and loss. So again, it takes time and really just practice of just being stubborn with the data, of forcing yourself to work through the data, of getting from, I know the input, I know the output, how can I get there, and how can I make sure a computer can get there? Not just me, but how can a computer get to that point? And we've looked at every single one, and we can see very quickly which ones we want to grab. We need to make sure we can tell a computer how to make that decision. So we need logical reasoning for the computer to make that choice. And so we found a way of telling the computer, here's your optimal house out of all the houses here. Here's the one you should probably start with. Sound good? Now, can I guarantee that this current solution will solve all the test cases? No. Might be an edge case here or there that might not work. But do I feel confident enough that this could solve a large amount of test cases? I'm feeling pretty confident that this solution we've looked at, this pattern, could solve a large number, which is what we want for the interview, right? So this, I would feel confident enough in this. And Jim, so in your question, at this point right now, I would feel confident enough working on this approach in code to get a large amount of test cases passed. That makes sense? I wouldn't care or worry that, you know what, there still might be some edge cases that I haven't tested yet. At this moment, I found that it can solve a good number, enough of them that I can get a good number of points off of this right now. I'm going to move forward. And I would pull the trigger on it and move forward. And then once I submit and I see some failed test cases, I'll first double check to make sure all the other ones are good to go. And then I might come back and figure out, well, why? What edge cases might I have forgotten? And then I feel like, well, at least now I can take a little more of a step back and take my time trying to find those extra edge cases that I didn't think of, because at least I've solved a good chunk of them and got a bunch of points. And so I don't have that stress of I have nothing yet. Sound good? So I hope this was interesting and enlightening. So, yeah, there is no one major item I can give you to say, here's how you solve all algorithms. There is none of that. None at all. It's really just trial and error, racking your brain, throwing stuff at it and seeing what you can find. But really, again, it's about finding patterns in logic. So those skills are key. Stubbornness can help in situations, but and never giving up. All right. Cool. So good luck on this one. I will definitely work on this with you guys on Monday. If you guys want to revisit this one, I'll touch base again with you guys after on Monday. See if we want to do this one again. But other than that, on Thursday we'll do React, and then most likely we'll be switching to the new schedule, like I said, on next week. All right. I'll see everybody on Thursday.
All right. Good night, everyone.
Good night, everyone. Good night.
Night.
See you
Good
then.
night.
Good night.
Good night.
Everything.
Oh, Cliff.
Yes.
I did just want to touch base with you on something. Next week I am moving. I'm moving
fun.
to a new apartment in Cranston, so I should have my internet set up at the new place, but it might take me a little bit to get situated. So if I'm out the next week, or like, I'm gonna try not to make it a big impact, but it might happen. I just want to let you know of that.
Gotcha. You're thinking at least Monday, maybe Tuesday too, potentially? Or the whole
It
week you're
shouldn't.
thinking?
Let me see. When are they coming? They're coming next Wednesday, so it might not be. So I might not be in next Thursday. I should be up by Monday the 28th if I'm not in on the 24th.
Oh, so you won't see me for my birthday.
Oh. I mean, my new place should be wired for Verizon. It's just a matter of how much can I get unpacked in that time frame, because
yeah,
I have a lot
send
of
me the message
junk.
on, and yeah, just keep me posted on text on your
Will do.
phone. In other words, so via Slack, phone, all that stuff. Just let me know if you're gonna be in or not. So that way I can be ready for it.
Sure.
Thanks for the heads up. Appreciate it.
Yeah, of course. I'm not imagining that it's going to be a dramatic impact, especially since we're this
Yeah.
close to the end and we're kind of doing our own thing. But I did just want to let you know.
Yep. Sounds good.
All right. Cool. I will see you Thursday.
See you Thursday. Hey, Jeff.
Did you still want to work on the thing tonight, or
I
you want to
do-
just reschedule?
In a second, I do need to work with. I need to talk to David for a quick second about his situation. So I'm going to put you in the waiting room for a couple minutes. while I talk
Actually,
to him
if you want, we can reschedule until like tomorrow if it's easier for you.
Sure.
You said that after your concert,
Yeah, that might be nice. I'd appreciate that.
because I'm not gonna lie, I'm actually really tired.
Go for it. I'll talk to you tomorrow then.
All right.
I'll give you an update on Slack what I can do.
Okay.
See ya.
Bye.
David. David. What was I gonna say? So for you, I feel like a while back I did ask, what is our plan for you? Are you still trying to level up in your current industry, or are you actually looking to change companies?
Well, I'm leveling up. I just spoke with my my manager,
Okay.
and they're putting the thing together. And I talked to him on the side, in the team chat. I can't really say on the side in the office, but they're
Right.
looking to offer me the position at 85.
Nice. Because I wanted to check with you what the plan was, because you really need to get out of here. You're good.
Oh yeah, but like
I don't want to get you out because you'll need it.
because the thing is even if when I get the job, I want to still like do like class like maybe once a week.
All right.
Because like it keeps my mind going, and like even though because like right now it's been hectic at work, and I've been taking care of my grandparents with Alzheimer's dementia because I moved them down here.
Yeah.
But,
All right, I get
to be honest with you, even though I'm not doing because like a lot of the stuff that I have at the job now is Java, right?
Mhm.
So they got a lot of Java stuff, especially like the application,
Mhm.
and doing this stuff actually kept me fresh because I actually wrote some dirty hack solutions with batch jobs and stuff.
All right.
So my boss already knows my worth. You know what I mean? That's the reason why
Awesome.
he's pushing through on it because
Yes.
like,
Well, if you need to build a resume or something, let me know, because that's the thing. We want to get you that option, because at least then you'll be considered an alumni, and then I no longer care. Then I no longer need to track you for attendance anymore and
Okay.
worry about that at all. Then you can
Yeah.
just, if you want to pop in, that's fine. But at least now you're more of a alumni teaching assistant kind of like person, and we can mark you off as graduated. And that way, if you're not showing up, I won't pester you anymore.
No, I definitely want to do that, and I definitely I need you, if you could, to send me the link for payments so I can start making some more payments.
I can do that. I'll talk to Arnell about that. Figure out what the link
Yeah,
is. and what the
like
plan is.
I need something where I can do it automatic. Like if I can just I don't know, send it to if I can send you a check to an address, or even like I don't know, like a bank account or something.
Create a Zoom chat with me and Arnell that asking for that. Because that way, because if he doesn't respond on the Zoom chat, I can at least not Zoom, Slack chat. Do a Slack message with me and Arnell mentioning that that's what you'd like to have, because then I can bring that up. If he doesn't respond right away, I can bring that up to him next time I talk to him. Be like, hey, did you see that message from David?
To me, it's just so much easier because if it happens, like
I agree,
like leaving my bank, like me making a bill pay or something like that automatic. It's not like, oh shoot, I forgot to make a payment or something.
Right.
You know what I mean? But I know that I'm going to learn that at the end of the week about the job offer. So
fingers crossed. And then
uh,
worst case scenario, let's just, again, I personally like the plans, but if it doesn't go through, what do you want to do next? So if they decide not to push you forward, do you still want to stay with them and try again, or would you want to look at another company somewhere
well,
local?
listen, I'm going to tell you, Cliff, like the job has its ups and downs where like it's busy and it's not busy sometimes. Like when it's not busy, you see I hand in like a whole bunch of work. You know what I'm saying? When it's super busy, it's like, hey, I'm trying here, but I'm still here for class, The great thing about this job is it's 100% remote, and the company's super nice. Like, and to be honest with you, I don't have to deal with bullshit, man. Like, not saying that U.S. jobs are all bad, but like, my managers, like right now, like I love my.
So no matter what, you'd want to stay.
Yeah.
Okay.
Just because of the environment that I'm in, like it's not 100% development, but I still use my skills because I have to go read through XML. I have to read through logs, which are, and a lot of them are JSON files and stuff like that. So a lot of that I learned from you guys. You know what I mean? So that's why I like keep coming to class and still upping my skills. I'll let you know at the end of the week it's pretty much in the bag, but that's pretty much
once you know the situation is talking, because we mainly just want to discuss are we going to consider you alumni and what's that look like? So that's the key. That's the key thing. Are you graduated or not?
Yeah.
Because right now you're still marked as a student, and so you're still being held accountable for like assignments and attendance. And so and honestly, yes, you do show up late a lot, which can be kind of a morale killer for some of the other students, seeing someone show up almost halfway through the class. So we want to make sure that if we can then mark you as like alumni who's sitting in to learn more and help classmates, then they might not care as much, and it will show a little better if you do show up a little late in class or don't show up at all, then they don't care, because then they know it's not like, oh, a student is not showing up and seems to be taking advantage of the class. It is an alumni and they're here to help, and they're donating their time. So it can be a better visual for the other students.
Yeah, listen, I'm more than happy to do that. So cool. I'll let you know.
Let me know on the other week.
I did, because St. Patty's Day. I know. Yeah. He talked to me on Monday. He said tomorrow we'll have it somewhere along the lines of definite. So if you get a slack from me tomorrow, more than likely it's because I got I'm permanently on the job. You know what I'm saying?
Just let me know as soon as you know. I got my fingers crossed for you. I'm hoping for the best.
Hey, even like contracting right now is, like I said, it's been great, and I'm glad that I stuck with you guys, and like a lot of the stuff that I learned in the class I've been using, like I said, and they don't know what to do with me right now, because like one of the biggest things that I learned from you guys is the API stuff. And now that I can read through their APIs, they're like, whoa, wait a minute. So that's great. Okay.
Awesome.
And I don't mean to be a morale killer. It's just
it's not you alone. I'm getting it from there's several students that do show up late. So it's not just you.